I'm Doug Fearn, and this is my take on music recording. This is part 2 of my conversation with Wes Dooley of Audio Engineering Associates. I asked Wes why ribbon microphones sound different from other types of microphones.
When I gradually learned, because I'm a slow learner, how to record, originally I wanted to know how things sounded when you aimed the microphone at them. And so I learned on axis and off axis. It wasn't until 10 years into it that I started to truly appreciate how important off axis was and how important it was how it sounded off axis. And at some point, I realized that to be a really good recording engineer, it was as important to know what the off axis characteristic of your mic was as the on axis. And I think I got that when I was using some Sheps figure 8s, and I was recording the All-State Honor Choir and Band and Orchestra down at the Convention Center in Anaheim, where we go for NAMM in that arena. And there was an overhead array, and I was trying to get the sound of the choir without the reinforcement they had. And I had learned with the Master Chorale and the LA Philharmonic to take my Sheps figure 8s and place them in the back of the orchestra, one at soprano, alto, and the other tenor bass, so I could get those two and have stereo. Because I didn't want a lot of mics out there. I'm not doing reinforcement. But I wanted good articulation, and this is before we had the wondrous thing of digital, so we could just delay those mics to bring them in total sync with the main pair. In that case, that was where we got heavily into MS. We had 3 MS stereo mics, AKG C24s for the Dorothy Chandler, because that's where the LA Philharmonic was at the time. And by getting those 3 mics all in really good positions, this was all Ron Stryker's work.
What is it that you think gives ribbon mics their distinctive sound?
I know that answer. We had it in one of the meetings with R&D this week. And I was asked, well, why don't you tell people that? And I said, well, you know, it took me a decade to just understand that off-axis response was really important. And that's something that as a good engineer, you want to know that at least as well as your on-axis. And that's one of the things, of course, I really love about ribbons, because we work with long ribbons. So if you take the vertical response, on a long ribbon, and ours are in the 44s, 2.35 inches. They're the longest around. And you go up and down, and you start to lose highs. If you're at the 0 degree axis vertically, you wrap around it, and boy, the frequency response doesn't change at all. Luckily, most studios are done on flat floors. So it turns out that you can get really, really good off-axis sound. It just sounds like being there, the level's down. And that's one of the just amazing things about ribbon mics, is that their off-axis sound and their on-axis sound for most studio purposes identical. It just changes level. And it really means that you sidestep a lot of the sort of things that are really dramatic when you're doing voice work with movies, television, and a shotgun just sounds, 30, 40 degrees off. It starts to sound weird. And of course, what you do is you don't have those people talking, but you certainly never use them for crowd response, and you definitely don't use them for things like audience response in recording our broadcast.
What about condenser mics that have a bidirectional position? Do they have that same characteristic as a ribbon?
Well, I fell in love with the Sheps when I went from my U47 and 67s to mics that were easier to use in the field, phantom-powered ones. But when I put the 87s up as my mains on Stravinsky's The Wedding, orchestra and chorus, I immediately noticed they didn't sound as good as the U67s had and that sort of stuff. Luckily, I'd also bought KM84s and 86s, and I had an Aura TF pair of 84s up, running 15 IPS 2-track B Dolby as a backup, and it sounded better. I lost a half an octave of the bass because these were small diaphragm mics, but it later became kind of my standard. And then later I learned with Sheps I could get my half octave back. The 4 series cardioid capsules just had that. And they also moved the resonance structure out to 80 kilohertz, so they were flat to 20. You know, I can go for a long time on the stories of the mistakes I made like that, and then the things I learned that made me a better engineer, how I solved those problems. But condenser mics in general, they use a tightly stretched diaphragm. Now you can loosen up the diaphragm and increase your sensitivity, but then you lose some frequency response, but then you can do the Sennheiser or the Rode thing and add EQ to take care of that. Now you have a quieter microphone in the critical 300 to 3000 hertz. But then you, of course, you've done some things that change the phase response when you throw that EQ in. And Sheps does a really great trade-off of having really little phase problems and getting better bass and having bandwidth. I mean, I discovered them when I fell in love with them. Then, of course, you run into things like, yes, but close up on a women's chorus, you start moving yourself up as close as you want to avoid traffic noise or such for the church they're in on a street that people drive on. And you realize that up there, you don't stand there and listen to the women's chorus. You listen to it out in the church where it sounds great, but you move up that close and it sounds perilously like IM distortion. And when I discovered that the first time, I used Wally Hyder's rule, because Wally always said, first you move mics around if you don't like the sound, and then you change the mics. You don't touch EQ. That's an emergency tool because you can always, in the field, back yourself in corners with EQ that are hard to get yourself out of. And all of that stuff is much better these days, but I work with you make the original the absolute best you can. And I haven't found any reason to throw away those lessons that Wally Hyder taught me when he was working at United Western with Putnam when I first met him, and then later when he started Wally Hyder recording. So I walked up to where the mics were because I'd had the excellent good sense to be running microphones in rehearsal. That's how the group sounded at that distance, but I couldn't move them farther out or I would start to have problems with traffic noise. And this is before Isotope and all these wondrous tools that dig us out of holes gracefully. And so I did the thing of I switched to KM84s, which are rolling off at 20, rather than the cardioid capsules on Sheps, which go out to 40 before they die entirely. And when I did that, suddenly it sounded nice because KM84s had that polite sound like Sheps preamps did. They rarely sounded bad. They fit really well a lot of situations. R84s, we realized we'd done that with that design, that we had gotten a really polite sound that had excellent response out to about 20 and then was rolling, although it actually goes out to 40K before it dies. So no one had done a ribbon mic with an 84, so I named it an R84 because both myself and Walter Sear at Sear Sound thought that particular design, which I had done as our first completely AEA design, it just worked out really well. As Jonathan with Rupert Neve Designs said, well, it's a currently made classical microphone. It's going to, like your R44C, which was inducted into the Hall of Fame, about 3 years ago. It's going to be in the Hall of Fame someday, even though we've never won a tech award. Hey, there we got it. It's in the Hall of Fame, the 44C. And we got other mics behind that are going to be there too.
You know, my experience with ribbon mics is, compared to other microphone types, is that they always sound to me like they're half the distance away that another mic would be in the same position. I don't know if you've experienced that as well, but if so, do you have an explanation for that?
Well, some of it is how microphones sound when they're close versus when they're far. But what you're observing, I've always really loved working with people who had some real recording experience, but didn't have ribbon microphone experience. I consider these naive professionals, and I pay a lot of attention to their response. And Julian David, who came over from Germany and was an intern with us for 6 months and liked it so well that he did a 192-page thesis on transformers for ribbon mics as the end of his 5-year, his diploma thesis at University of Dusseldorf. He came back and spent 5 years with us. He owns our mics and uses them in his studio in Cologne. And he has lots of experience with microphones. He works currently with the Townsend people on the Spheres. But ribbon mics are just a different animal. And part of it is that excellent response around the horizontal axis. Part of it is just that they sound totally different, because earlier I commented about the resonance structure of condenser mics is stacked at the top end. And their resonance structure is that thing that gave a special articulation to the U47s and all the other large diaphragm microphones. It's the sort of thing that sounded just splendid with tape. I was modern. I had a 47 and then a pair of 67s. I didn't have a ribbon mic until I'd after worked with Wally, but when he worked with his favorite music in the world, the big band music, Stan Kenton, he followed him around a European tour with a remote rig. His first own studio was at the corner of Selma and Coinga, and that was because the alley behind that went right down to Shelley's Manhole, which is where all the jazz played. It was one of the best jazz places in town. So he could just run a cable down the alley and do jazz sessions using his own control room. And he put ribbon mics up in front of the brass, woodwinds, all that sort of stuff. And I went, what's this? You own enough Neumann and other, C37A Sonys. He had a good mic locker. And he said, no, I used the best mic possible. Remember, I told you that if you didn't get the best sound you could, move the mic around, and if you didn't like the way that mic sounded, try a different mic. Well, I've tried all these mics, and the old guys taught me to put ribbons up on these instruments because, boy, they sound better. And one of the things they sound better is at a distance. Now, I talked about working with people who are naive professionals and getting their read on ribbon microphones. And the reason I'm still in business is, boy, there's still a lot of naive professionals. And we've gotten a lot of them, and they are now fans, sometimes just for one use, sometimes now for a lot of uses. But ribbon microphones just make the job easier. And part of it is that sonic characteristic you noticed. They sometimes sound great at a distance. And sometimes that's the best sound you're ever going to get. And why are they different than condensers? Well, I commented earlier about the resonance structure of a condenser, especially the big diaphragms. They have a lot of high Q resonances in the 8 to 12 kilohertz region. And of course, with some sibilant singers, that's really horrible. And until we had isotope and other things like that, that was really hard to get yourself out of. And so you changed the microphone, or you moved the angle that the microphone was at. You did whatever you could, and if you were paying attention, you made it easier for the people mastering, because high Q resonances are not kind to disc mastering. And they're certainly not kind to the early days of CDs, where we had these really steep filters on the high frequencies, so we didn't have aliasing problems, but they certainly didn't like high Q resonances. So as soon as that stuff came in, suddenly people who knew ribbons and had been using them some realized that they could do a lot of stuff with ribbons and not cause problems with the digital transfer. That ribbon sounded wildly better when you transferred them to CD. That you kind of knew what to do to get around the problems when cutting a disc master, but we weren't quite there. We were still learning about how to do digital CD masters. So what was going on, of course, is that ribbon's main resonance is down at low frequencies. And with the really long ribbons we use, the 44s and such, from the 20 years experience we had servicing since RCA dumped the division in 76, to when I started tackling, let's reissue a ribbon microphone to celebrate surviving cancer, I really got into it and took a look at what we'd learned in 20 years of servicing the 44s for people like the guys at Capitol who have a dozen of them, and the people who hide them away at A&M records and such, but let people who really know what they're doing use the mics, because once you start using them, you don't stop using them. And once you have been introduced to them as naive professionals, you start going, and often don't talk to other people because it's a secret weapon. It's a little less secret these days, so I'm going to tell everybody the real secret here. The resonance structure for a 44 and all our big ribbons, we have that down sub 20 hertz. You don't hear it much. The small, short ribbons, where that resonance structure is in the 30 to 60, 70 hertz, ranging from Cole's 4038s, the BBC-derived design, to microphones like the most of the current crop, which are ribbons in the 1.5 inch range. They're tuned up pretty high. And of course, like loudspeakers, when you look at the impedance versus frequency curve for woofers, which have their resonance structure down where a lot of these ribbons do, you'll notice that the impedance kicks up dramatically. The one that did that the most and got written up in 55 as an AES paper by a RCA engineer is the RCA 77. That would typically be tuned somewhere in the 45 to 70 hertz range, and the impedance would move from a nominal 250 ohms at 1,000 hertz. It would kick up to 1,800 ohms, 1,600 ohms at resonance. And one time, since we knew these problems, and in 05 did our first D-ribbon pre, the TRP, which is now to a Mark II with phantom power, and then later our RPQ series, now the RPQ2 and the RPQ500 with phantom power. Those are very high input impedance if you're not using phantom power. We have our phantom power set at about 10K. At the TRP we said, probably something like 20K, and we actually were about 33K, and now are 66,000 ohms. Why did we do that? Well, we did that to sidestep the problem with resonance, because the first time I loaned a TRP to a guy who did a lot of recording with 77s, but used the stuff he thought would be best with it, a tube preamp with transformers with an input impedance about 1,000 ohms. He bought our stuff because, as he said, I have bass now. I didn't know the mic had any bass. And I said, no, it was just, this is how it works when you're using passive ribbons. Everything out through the first tube or the first transistor is part of the circuit and will change the overall sound. And, when you hit that resonance and you have, as the guy who did the RCA paper, or the RCA engineer who did the AES paper in 55 said, some of the RCA preamps, because it's expensive to do a transformer that holds up its input impedance at very low frequencies, they had some stuff that the input impedance at 1,000 ohms for the preamp would be 2,500 ohms. That's really nice. That's 10 times the source impedance. However, that same unit at 50 hertz, its impedance was down at 600 ohms. Now, if you drive an 1,800 or 1,600 ohm source into a 600 ohm load, you have a deep dip there compared to being 250 ohm source into a 2,500 ohm. And luckily, I was raised in a period where if you didn't build your preamps, if you didn't know how to build stuff, you probably couldn't have what you needed for the job. And so we were building our own stuff from early on. This is back in the early 60s, even before we started Audio Engineering Associates together in 64. We knew enough to say, how about doing a dedicated preamp that makes things really good and doesn't get in the way of this resonance structure so that you get the bass and you get better to signal the noise because you're not loading down the microphone. Because only for voice telephones did you need to have a 600 ohm source and a 600 ohm load so you could get as much power as possible and make it as loud as possible at the other end, because all there was your 600 ohm carbon granules being shook up a bit by you're yelling at the thing right there, and your 600 ohm receiver at the other end. And there was nothing but copper twisted pair in between. And that's where, of course, everybody got used to the idea that they're supposed to be the same impedance. But as soon as we got into electrical audio in the 20s, that changed. And even the BBC, who did the Coles 4038 ribbons as a matching impedance, 300 ohm source, 300 ohm load, they eventually stopped doing that because you gain about 6 dB of signal to noise. If you don't load down the microphone, and of course, even though that mic, which was really well designed to not have much of a bump at resonance around 40, 45 hertz, it did go up to being a 600 ohm source impedance instead of a 300 ohm. So, at 50 hertz, 40 hertz, there's a dip in the response. And sometimes you like it and sometimes you don't, but most people working with ribbons have no idea that as soon as they are working with a passive system like that, everything they add on to the circuit is part of the EQ. The capacitance in the mic cables, resistance in that, the capabilities of the transformer, what its impedance curve was like, all of that is part of the sound. So until people tell me what the entire chain's like, I can't make any really cogent comments to people about what they're doing that they might or might not like to change with passive ribbon mics. Now, take us back to the subject. Why do ribbons sound different than condensers? because there's one more part to that. And that's the part I was talking to the guy who is one of our key people in R&D. And he asked that question. I said, okay, there's one other thing. And I told him, he said, why isn't it in any of our literature? And I said, no one ever talks about it. I suspect because the only people who really know it are the people who design mics. And what you do, of course, is design mics to sound really good. And you don't necessarily want to give away the information to anybody else. It took you a lot of years to learn that. But, you know, we do workshops with other boutique microphone manufacturers, Cloud in England, Extinct Audio, Feather up in Seattle. Yeah, those of us who are really into it know these things. And we talk about it among ourselves. We sometimes actually get together and have chances to just, not now, we can't do that play person to person, but we've had an international conference here at AEA where we looked at things ranging from how are ribbons truly different to how can we make sure that we continue to have ribbon material, because we use really exotic materials, totally pure as we can get it, aluminum, that's been hand-beaten. You know, there aren't many people who do that anymore. Just like there aren't a lot of people who make really, really pure ribbon material, the aluminum, anymore. And we're all in the same boat together. So we get together and talk about these things. And we solve the problems. And AEA is the biggest of that boutique group, takes a lead in it because, we were kindly taught this stuff by John Sank, who was in charge of ribbon mic production and design later on at RCA from when he came there as just graduated from college to when he was the senior guy in 1976. 16 years he'd been there. And he took the time to show me how to do a 44 ribbon, how to make ribbons crinkled, gave me the tooling because he said they were throwing it all out. I have more than I need. So gave me lab tooling and gave me ribbon material, which I chased down, eventually got and met the guy who had it made for RCA, and he got it from Germany. I chased those people down, and it turns out they'd gotten it from the 20s on from Italy. You know, we've chased it all down. We've been doing this for a very long time. So here's one of the things I've learned in that very, very long journey. Because I said I don't learn things fast, but I am curious and I am persistent, and I fell in love with what Wally Heider taught me, which is change the location of the microphone and then change the microphone itself. Because what you want when you've been doing your recording is just to have everything on the monitor or the console up at 0. And you want that to sound remarkably like what you're going to release. And then what I learned as I went on was single ribbon mic is astonishing. Yeah, I got told stories about it. Dave Gold is still alive, and I get to talk to him occasionally, who was the technical side of Gold Star and built all those consoles. He said when they opened in 1950, the only great mic he had was a 44. As Les Paul told me, the first great music mic, period. As Les said, as everything else in the chain got better, the microphone just sounded more and more like the music. We're really, really good at this point, and we fought really hard to make 44s that on a nuance level are better. But we started with such a great foundation. It has challenged us all these 20-some years just to not be disrespectful of the tradition we've kept going.
I've been talking to Wes Dooley of Audio Engineering Associates. This is my take on music recording. I'm Doug Fearn, See you next time.